Hey, Kevin.
Hey, how's it going?
Let's see. I should probably get agenda and stuff going.
Do we have stuff on the agenda?
I do have something I wanted to bring up. Um, do you have any items?
I don't.
Okay.
Taylor looks like he's speaking with unmute. You don't look like you're muted, but I couldn't hear you.
Okay, well, we'll use this one instead. Every single time the last, or at least I should say, last couple months when my Blue Yeti hit like the Logitech app is updated, it just like says, please unplug and replug your device. And always like that. And I have to figure, the only way can fix it is restarting my computer. I have to figure out how to like kill the proper kernel extension or something is my guess.
All right. We are 7 minutes in. I am remiss. Let me give the preamble and let's get going. Hey, everyone. Folks that are joining us online. This is the WASM Working Group under Tag Runtime within the CNCF. My name is David Justice, and I will be, I guess, chairing this meeting. Um, we follow the code of conduct for the CNCF. In short, please be kind to each other, raise your hands, you will be recognized. And so without further ado, let's kick this off. Looks like we have three attendees and one agenda item. If you have an agenda item, since it's kind of sparse today, please feel free to fill that in. And if there's anything you would like to bring up in a meeting in the future, please feel free to jump into the agenda. You'll find it under uh, the WASM Working Group. What is it?
Wasm Working Group tag runtime section in the tag runtime site.
Yes, yes, thank you so much. Great, words elude me today. I need more coffee. Cool. So, hope everybody's doing well. I have an item on there to discuss, and basically, I was going through implementing the latest version of key value for spin. And so this is 020 draft 2, where we have added in increment, swap, and some batch operations. Um, one, all right, so I'll start off with the easy question first. uh, Get many returns a vec of, actually, let me bring it up because it'll probably be easier to talk through. Uh, all right. So we'll go batch, and I'm going to share my screen if nobody objects. Some sauce. Okay, cool. All right, can folks see my screen with GitHub on it? All right, groovy. Okay, so if we look at get many, and this might be something that's trivial for us to fix, or just like, hey, we're cool with it one way or the other. So get many, our result here is a list option tuple of string and list U8. This is pretty standard to what we were doing with get. However, there's uh, a slight change between get and get many that's subtle. And this may be something we want to change. So if we go into store wit, and we go down to get here, we see it actually returns. So for the string, the key passed in, it actually returns an option of list U8 as opposed to just a list U8. So the assumption there is that this thing could be nil or could be none, right? And in batch, what I would expect for paralleling to get would be a list option tuple string, but list or option list U8 at the end here.
Yeah, I think that
Thoughts?
makes sense. Yeah, this was all these changes were made very, very fast, I think, with based on
Yeah.
some feedback, and we just needed the options somewhere. And looking at it again, I think it makes more sense to have a list of the tuple and then so list tuple, and then in the tuple, the list is an option, if that's what you were saying.
Oh yes.
Yeah.
That is exactly it. And Calvin, do you have any thoughts on that?
So just to be clear, though, the option is when there's a key but not a value. Is that correct?
Yeah, so let's imagine we pass in that list of keys. And I'm thinking that what we want to get out of there is the same list of keys. However, some may have none values. Does that seem reasonable? Or should the list of keys that we're sending back be all right? So you can imagine this from the SQL query perspective. I say, give me all keys, uh, key in this set of keys. And what projects back is actually a subset of the keys that are in, right? So let's imagine we pass in 10 keys, six exist. Maybe two of those have nil values, but they exist. So the projection coming back out would be of six keys, some of them having none values. Or is it actually, it should be 10 keys with possibly some having none values.
It seems like returning the key as part of the not only the key but the key value, like that tuple, as opposed to just returning like the value, and if the value's like keeping the list length the same and corresponding. Like it feels like there's two different ways to do it. We're kind of like mashing them together right now.
Yeah.
Um, I I could see it both ways. It does feel like, yeah.
So
Do
in
do
this
we
case,
do you think
in
it's
that,
yeah? From looking at the implementation, do you think it's valuable to return the key again in the result?
I think you need to.
Okay.
And let me explain why I feel that
Okay.
way. So when I look at, so for me, parity, symmetry, we all like symmetry, right? When I look at 79, line 79 get, and I see their result option list U8, because we passed in one key, we already have the assumption that we know what the response corresponds to, so we don't have to align those. However, the option U8, what that's telling me is, hey, I'm going to go ask for this key. I might not have anything there. It doesn't tell me if the key exists or not, which is a different operation. And maybe one of the things that we may want to consider from the result here, if we, you know, okay, none, key does not exist in the store, returns okay, none. Um, maybe. So this started to lead me down that direction of, okay, we want to return everything, and okay, none means key doesn't exist. Now, is that really true? Like if we in All right. In no case in set, we actually send a none. So we expect there will always be something there for a value. So if we set something, we have to give it a legit vec of U8. It could be an empty vec of U8, but it has to be a vec of U8, right? So I'm not sure that this is actually 100% true, that OK none is actually means that the key is not in the store. Um, I think we could go with that. I think we could also say, some other variant, but that's a little bit more in the weeds. Let's understand here that it is possible for us to not have a key returned or have a value returned because the key does not exist for get. So if we go back into batch and we say, what would that feel like if we had a key not returned? Um, would it be list option here? So we have a list of keys. Let's imagine the first one comes back. It doesn't have a value. I think that is just us saying option list, and we can get rid of the option in the front. So we're always going to have a tuple sent back. We're just going to have the string key and then the value associated to it. That way, you can always say, hey, I pass in these keys. Maybe I don't have values for them, but I'm going to get them all back and I can see them, in relationship to each other.
So just to reiterate though, if the list on the return was the same length as the list of the keys that you're passing in as the arg, and they were like ordered the same way, we could probably drop the returning the key again, right?
You could. Yeah, that's the trick.
We had it
So you
that way
could do
once
that.
upon a time as well, but it didn't indicate if a key was missing, which is why we went down this route. So you have trade-offs associated with each one. You're sending a little bit more data when it comes to key values, like being sent back along, like the key themselves being sent along with the value. Um, but it gives you the idea of telling like if something is it actually exists or not. So that saves you some other round trips back and forth with it with a database as well. So I mean, I've seen both options happen. I personally feel like being explicit is better than implying something. Um, so it's also hard, like with the implied one. Okay, if I pass 10 keys and two of them don't exist, which two values aren't the ones that are associated with like my list of keys, right? Was it the seventh and eighth one? Was it the first and second? Was it the ninth and third? Like you don't know. And so this feels like the way to be the most explicit. I just think swapping the option to the list makes more sense because then rather than trying to match the order, you always have a key. Which is what this was doing, was trying to match the order. Like you said, it kind of ended up being a mash of the two. But I think we can just probably say, you know what, I'd rather be explicit about it. If you pass 10 keys, you're going to get a vec of 10 keys back, and they may or may not have values. And if we're going to be changing this, it might be worth changing it from a tuple to like a key value result or something, like so it's a struct, but we can keep it as a tuple too.
Yeah.
I don't care.
So because we're passing in a list of string here, should we, I just want to be very clear. We should get rid of this option, the first option.
Yeah, get rid of that option and make just the list itself, the list U8, the value optional. That's what I would do.
Okay. All right, cool. I'll throw in that PR today.
Okay.
Thank you so much. Calvin, do you feel like that's a reasonable path?
Yeah, no, I think I'm indifferent. So it does feel like this is the change that you're suggesting should happen. I could see it both ways though, on like how to, you know, iterate on this in a couple different ways. I'm indifferent. As long as it's well documented on the expected behavior, and maybe also specify in the comments like if things can be reordered or not in the
Yeah.
response. or the order has to be, like, just as long as the behavior is well defined, I don't care.
Yeah, that's the thing. With reordering, if you're providing a key, you are less susceptible to issues with reordering, right?
Yeah, exactly. So
Yeah.
if you're loosening that restriction, I would probably just add in the comments like can be reordered or something, or assume reordering is possible or something, or acceptable. Um, just to be explicit on the behavior.
Yep. Cool. I will also add that.
Cool.
The rest of the batch looked good. Um, Atomic. So I have two pieces of feedback for Atomic that might be helpful. Or just noise. How would we feel about taking swap and actually moving it into the resource?
Um, David, you and I had this conversation starting over chat. Um, I thought, but I could be misremembering. I've done a lot of writing of random wit since then. That resources can't consume themselves. They're all like essentially like borrowed self parameters when you have like, so if we put swap up there, it'd be swap colon func and then the value. Um, and then you still have the handle to the operation. So when I designed it the way I did, it was to make it like make sure you're not shooting yourself in the foot, because like if you don't pass the resource back, it basically means that you could be holding open something, or there could be weird things depending on the implementation, right? Like you might not have finished a transaction, or you might not have done something along those lines, and it could result in some weird behavior. So that's why I did it this way, was because it said, okay, I'm going to take and I am consuming, like this is taking ownership over that resource. So in Rust, it'll mean you literally can't use it anymore. And any other language, it's going to be clear, like, no, like this is a resource that you've passed in. Like it follows the semantics of everything else where you can consume. Just like how I hate quoting HTTP as an example because it's terrible, but like, that's why I'm so excited for Preview 3. But like you have to pass it um, the actual like stream thing for it to finish it.
Yeah.
And so this was trying to follow a similar thing. I understand it makes more sense on the resource, like from a programming standpoint, but I was trying to model it in a way that made sure resources were handled properly. So an implementer would know to like, okay, I got this. I'm going to eject it out of my resource table now, and I'm like, it's done. No one else can use that.
But it's stateless.
What do you mean?
Cass Cass is stateless.
It's not stateless if you're using transactions. You have to have like that transaction that you're tied to, because some of the key value provider type things would have a transactional type thing going on.
Oh, and so you're actually running commit at the drop?
Yeah, when you do swap, it would be running commit
Right,
exactly
right. But are
underneath.
you doing that in your drop or are you doing it at the end of the swap call?
End of the
So,
swap. Oh, well, in both cases, I would be dropping that transaction. It just depends on the intricacies of each implementation. Some of them, like if you fail, like if it
yeah,
fails, like comparing, you'd have to like or you like normally in the transaction you do the compare once you have the value. If
yeah.
that fails, then sometimes it returns back a new handle or returns back the same handle. It just depends on like, and all the ones I looked at, it's a slightly different thing. And so it might be on drop, it might be right after you swap it, but like this makes sure that it controls the drop and the swapping behavior. Essentially, like
Okay.
what this was trying to indicate is once you have used a CAS resource to swap something, you can no longer assume it's valid. Trying to do something with it again is undefined behavior. Um, because of the
Interesting.
state, because of the state there, because something like you said, some things it's stateless, but for some things there's state, so it just depends on the implementation.
So, in the way that I've thought about it is when you're putting in, um, the key and uh, so in new, um, let me start over. In new, do you expect a fetch to happen with the data store in new?
Um,
Or do you expect that you have to call current?
you have to call current. And this was explicitly designed with that in mind. It's avoiding a round trip to the database if you don't like, because you could just say, no, please swap this, and for like some things, it's literally going to take the old value and compare it underneath the hood. You don't know. But for other ones, it's just going to try to commit it. And it's going to try to commit it in an atomic order based on other transactions that might be in flight.
Okay.
And so new does nothing but basically, like, for a transactional database, it would open up a new transaction, save that transaction, like whatever the struct is for that transaction in the language internally that's mapped to the resource, and then return the resource. And then if they need to, they can do current. For some things, that will mean that it's going to do like the get directly. Sometimes it might have already pulled it down. Like I know that if I were implementing this for like the Nats KV thing, when I do the initial thing, I'm just going to be grabbing a revision number, which means I have the value. So I'll just store the value in the resource so that
Yeah.
when they fetch it, there's actually not anything going on. But it gives that flexibility. So current is optional. And then swap will let you swap the two if you wanted to when you finally are ready.
So
Okay.
yeah, good.
No, please.
I was just going to ask a quick clarifying question. So if you call right now how it is, if you call swap and you did not call current before then, what is it going to do? Like, so
It doesn't matter. Current has no impact on the actual swapping of the thing. All that it's doing is fetching you the current value of that key before you do
No,
any swapping.
no,
so
no, 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 no,
new,
no, no.
because
I,
that's different behavior than what you're just describing, I think. Because it new
yeah.
either calls, initiates a get or something to actually get the current, version number or whatever we want to call it, or current does, right? So if, right, like, but one of those has to make the call or both of them.
Because you're not passing in and swap the revision or the previous value or any of that stuff. So either new or current has to be called to populate that. And if we are populating it, or if that's the expectation, then when swap gets called, it's going to need to probably raise an error if new or current had not populated the revision number.
Um, new will always have a revision number. The thing is, this is where it got loose. This is why you and I kept
Okay.
going back and forth and came up with this in the first place. When For those who might be watching this later, David and I just kind of like brainstormed after we were trying to figure this out, and it's because of the differences in each process. Because some are literally comparing the value.
Yeah.
It was less than I thought it was. Fewer of them are comparing the value. If the value is important to compare, most people did that within a transaction itself. So they'd capture the value they're comparing, like they'd fetch. So like inside the transaction, it'd be like tx.get, and then they'd get the value and they compare it inside of there, and then they do something. Um, so that flow, there's one more flow beyond that. Let me just finish that. So the other flow that's in there is that it's purely transactional based. It's just like if you were doing it against a normal SQL transaction, right? And saying, okay, I've started something, I'm going to do these operations, and I'm closing the transaction. Then it tries to execute in an atomic order based on other transactions, which doesn't necessarily do a compare of the value. And so the current was meant to be around that. This is the current value of that thing. It gets it for you. So like then if you are trying to do the literal comparison, then it's reading the data out. You might have a like megabyte value if you're talking about largest size. And then it'll read it out for you. And then you can do a comparison, because then if you try to commit based on something different and it said, oh, that value's different, like you can try to do it. You can do it that way as well. So it supports that middle one. It's not perfectly like, but to be able to support all of those, we had to kind of make one of them at least a little awkward. And that's the one that's a little bit awkward when you're doing a direct compare of the value, which is why you fetch it with current. The new should do anything it needs to do the like checking. If that's just fetching a revision number or like a CAS ID or one of those kind of things, great. If it's another system where it's like, no, you have to compare the value, then you fetch the value as well. But like that's opaque to the user is supposed to be the idea, and gives things that have the possibility of optimizing that away if someone's not doing an actual compare, to not have to load the value if they don't need to, which is why they have the current.
Okay.
I'm not married to this idea, by the way. I'm just going over the like why we kind of like put this all together and why I think we did it. I'm not beholden to it. I'm okay to change. That's just kind of where I was thinking, is like one of the different options has to be awkward. And based on our investigation, looking through all the different, you can go back to the issue and look at all the different things that are used. There's very few that actually do a direct, have implemented some of the other stuff and been fine. The CAS one we haven't gone to and implemented yet in the Wasm cloud providers, so I can't tell you. But I'm okay. Just if you have the feedback, I'd open up or change whatever feedback you'd like to there.
If you wanted to make a small structural change, you could make swap inside of the resource as a static. That wouldn't change the behavior of the ownership transfer.
Yeah, that's the other thing you could do. You could make CAS have a static method that takes CAS to consume it if you wanted to group it better. I'm that's more organizational to me. It's functionally the same, so
I actually screwed this up, so it actually should be this. 2, and the value, actually, value's 3, sorry. So here's the implements so far. So compare and swap ends up just opening up populating a resource with the name key and the SQL connection. Oh, and there's value here. Value is so we get the value, what the current value is on new.
yeah.
We store that in the compare and swap. Within the compare and swap, when we call current, I'm just going to return you back whatever that value is. Then in the swap, we're actually going to create a connection, or we're going to use the existing connection that we have. And then we're going to run an update. And this update takes in, pardon me. Thank you. So this update compares the key, the value, and the store. So you can imagine in SQLite, within Spin, they separate it out by store. So it's just like one table, but store name is one of the columns. Anyway, so you have key, value, and store, and then we just do an update there. CAS should fail if no rows are updated, and that indicates a CAS failure. Now, you could also imagine doing this in something closer to what we're doing with increment here. So in increment, we start a transaction, we go through, grab whatever the data type is, and cross our fingers and hope that from Little Indian Bytes that we have a int 64, and if not, then hopefully we'll just call it a 0. But eventually committing the transaction at the end of increment. This kind of works, but this kind of goes into the next set of questions around increment and what the store should be storing. And there's an issue out there from
Pat Hickey opened it.
Pat, yeah. Which that's one we should talk about it possibly next. But I think this is part of the exercise of, after we define these, actually implementing them and feeling what it feels like to implement. So in the case for SQLite here, there isn't a need to call current. and current is relatively superfluous. But we need the behavior of providers to work the same. So you're probably going to want to call current to say, hey, what is the current value? Because I'm operating on it. I'm going to make some choices now and do a calculation and then update that current value to the next value. So that's the transaction, right? So you could in new or in current start a transaction. Now, this gets a little weird because if you start a transaction in one of those methods, um, you either have to drop it, you have to commit it or roll it back in drop. Like basically in drop, I would want to say, hey, um, do I have a transaction running right now? If I do, then I want to roll that back. I don't want to commit that because in drop, I'm going to expect that swap has completed my transaction. And the only thing I should do in drop is if I still have a transaction running, I just need to terminate it and roll back.
Yeah. So here's the way I picture this. Let me walk through a couple of flows. So drop should always try to close the transaction if one exists, because you don't know if swap is run on it or they just dropped the resource or got rid of the resource. Totally. I still like current. How I picture it going is, let's say your thing is purely transactional, so you wouldn't even fetch the data until you get into there. Um, you can probably, like, what I would do is have current like reset a transaction ID or reset, like current can do other things inside of it to reset the transaction. So it would come in and say, okay, this person is wanting to do current because I have seen an equal amount of both types of operations. A lot of the ones I've done recently, for example, don't even compare. All they care about is if I'm incrementing the right, like if I'm using the right ID, like revision ID or whatever ID to move to the next value. I'm not doing a compare on the value. Um, and like I said, but I've done the other one too. They're both equally valid. And so in the case where I'm doing a current, if you're doing a transactional thing, what it would do is say like fetch the value when you start the transaction or whatever, and then put it into there. Or if they call current again, you could reset the transaction. I don't really care. Once again, it
Okay.
was meant to be as opaque as possible. So like you could say, okay, fetch this and then keep the transaction in play. But if they call current, kill the current transaction, get the new value and then a new transaction inside of the resource handle. They won't know that that happened underneath the hood, but like you could do that. And for a revision based one, they may
Yeah.
never call current. And then you just continue the transaction and then close it inside of swap. And then when you get to drop can say like, oh, like there's the transaction isn't there, or just say like, oh, the transaction was already completed or aborted or whatever, and ignore that error. Um, it's not perfect. I'm also okay to say, you know what, like everything has to have a current value set, and then current's just a getter for the value. That's okay too. If it ends up being less awkward, we can just change the documentation for it. Um, it
I mean,
yeah, I'm just trying to adapt it onto the, like making it so it's adaptable onto the most options possible. This is why I had avoided CAS in the first place, because it's one of the worst kind of problems, because it's not like, okay, there's three completely different ways to do this. It's like, no, they're all like, minus the literal compare and swap, which is rare, they're all kind of similar. They're either using like a CAS ID or they're using a transaction basically as a CAS ID. So it's like, it's just slightly different enough that it causes issues.
it is, and I think we really need to spell it out for people. This is the expectation. But it's probably just, I think it's just going to come from uh, us doing it. So, what the hell am I doing?
So swap is going to consume the CAS resource, right? So it effectively that call will do a drop in it. So
Yes. And then implementers like in Rust, the CAS resource should implement drop and close any, if you're doing a transaction, close out the transactions. Other languages is a bit different how they handle resources, but like that's just general rules. So we can update whatever documentation you want to here, David. Like I said, I'm not married to any of it. I'm just going over the kind of thinking
I
I
like what
was
you're
going
saying.
through.
I like what you're saying about current. I think what I'm going to do is I'm going to move out of like instead of fetching on new, what I'll do is I'll fetch in current, keep updating current, and then because I didn't include revision on this one, I should really to do this well should probably put revision into the schema
Mhm.
and have a timestamp column and then use that for optimistic concurrency. Um, however, uh, just doing it for expediency, I was just comparing value. So if current gets called multiple times, it'll keep fetching what is the current value. And then you could reasonably use that to swap. The interesting part is with that, you could reuse that cast. That cast doesn't actually have any state associated to it, right? Other than the value and the key. And you could continue calling current on it for the rest of your life if you wanted to, and there's no transactional implementation. Um, interesting, but would also probably break other scenarios where the expectation is that that is consumed. And I imagine creating new resources are relatively cheap. So um, in that situation and swap, if it fails, uh, I will end up probably creating a new cast resource and then returning that in the error. And this is one of the kind of odd parts is so um let's see where was it if there was an error in uh, I'll have to write it up, but basically uh you're going to need to create a new cast resource to return it with the error variant because the error variant takes in as a parameter uh, the cast resource itself. Just as heads up. So that'll be a little bit funky for folks. All right, I'm going to stop sharing.
It, I think we should move the swap as a static into resource, maybe for grouping, because that also is a common organizational pattern in the other WASI like WASI HTTP does that, for instance. Is it, you know what I'm getting at? Is
Yeah,
like make it a
yeah,
static method because it's the only other one that's like in there that has the cast and it's not in the cast resource. It's just a structural thing, right? Doesn't change the
yeah.
behavior.
Um, well, now we have a little bit more insight. Think about what you would want to see from that interface. Um, I realize that I have to drop off here at the 15-minute mark to hop over to another meeting. Um, Taylor, do you think, or Calvin, would you be okay running the rest of the meeting?
I also have to leave at the 15, so we should probably just call the meeting.
Yeah, we just got ended early.
I have to
I'm
go
so
host. I have
sorry,
to go
gentlemen.
host Cloud Native Live. So
Yeah.
This is a really great chat. I really appreciate it.
Thank you for going through these details. It's good to see the implementation. Cool. See you guys.
Better y'all.